We're going to start chapter 6. This is a very important chapter. It's about factoring polynomials. This is going to be an operation that is going to be something new for many of you for the that you're going to see for the first time. So it's important to understand this process because this is a new operation that you're going to learn that is different from previous operations that you learn in math. So chapter 6, we're going to try to remember that when we have multiplied two polynomials, let's say this is a monomial times a binomial, you apply the distributive property here. So you multiply this and this and this and this, so you're gonna get something like 5 times 2 is gonna be 10, x times x is gonna be x squared, and finally 5 times 3 is gonna be 15, and x, that is gonna be the result. So when you go in this direction, you're applying the distributive property. But sometimes, and this is going to be very often, we want to go in the other direction. We're going to start with this algebraic expression, and we want to recover the original factors. So we want to recover the factors. So, and we call this process factoring. So factoring is going to be just undoing the distributive property in some sense. So this is going to be the work that we're going to do in this chapter. So we're going to have a lot of algebraic expressions, and we need to process those algebraic expressions to be written in a factor form. So we need to have a product of some algebraic expressions that are going to give you the algebraic expression that we're going to start working with. So we're going to start with section 6.1. So it is possible that some of these concepts you already know them. So section 6.1 is about the greatest common factor. I think you have heard about that in previous courses of math. And then we're gonna work on factoring by grouping. So this is gonna be the first method that we're gonna use to start working on factoring. So the greatest common factor and factoring by grouping are the goals for this first section. So section 6.1 starts on page 420. So the greatest common factor and factoring by grouping. So to find the greatest common factor of a sequence of terms, we're gonna get the greatest common factor for coefficients, and then we're gonna multiply that by the greatest common factor of the variables. So how are we gonna find the greatest common factor of the coefficients and the greatest common factor of the variables? I have here just written a small definition of each. So the greatest common factor of coefficient is going to be the greatest integer that divides all the coefficients evenly. And by that, I mean that you're going to get an integer, not decimal numbers. And the greatest common factor for variables, the definition is very simple. The way that you find the greatest common factor of the variables is very, very easy, but sometimes students make some mistakes. I'm going to mention what happens. So what is the greatest common factor of variables? Is the variable with the smaller power, greater than 0, of course, because you know that you can raise any variable to power 0 and you get 1, but this is just, you miss the variable vanishes. So the variable with the smaller power, and this rule applies only if the variable is present in all terms. I'm adding this from my previous notes from previous courses because students found greatest common factor of variables when there was a term without a variable. So you need the variable present in all terms, in all of the terms. Otherwise, your greatest common factor for variables is just one, it's not any variable at all. So I'm going to solve some problems. Maybe we need to start with the example that is shown in your book. So they say that we need to find the greatest common factor of the following expression, 10x squared plus 15x. So what is the greatest common factor of this expression? So we're gonna find the greatest common factor of the coefficients first. So what is the number? The integer that divides evenly 10 and 15. You know that 5 divides 10 because it gives you 2, and 5 divides 15 because it gives you 3, and 2 and 3 are integers or whole numbers. So 5 is the greatest value. There is no other number greater than 5 that can divide 10 and 15 evenly. So that's the greatest common factor for coefficient. What is the greatest common factor for variables? I have the variable x that is showing up on both terms. So that satisfies the criterion that the variable is present in all terms. So we have an x here, I have another x here. So x is going to be the variable of interest. Now I need to find just the lowest exponent. What is the smallest exponent? In this case, it's just 1. So that is the greatest common factor of variables. So what is the greatest common factor of this algebraic expression? Is going to be the product of these two. So it's going to be 5x. And you can see that 5x is one of the factors. So we're in the right track to learn how to find the factors so that we're going to be able to do factoring. So let's start with the first example. Example 1. Let's see, example 1 is on page 421. So we're going to find the greatest common factor of each list of monomials. So in the first case, I have 6x cubed and 10x squared. So first, greatest common factor of coefficients. What is the number that divides 6 and 10 evenly? Is 3 that number? 3 divides 6 evenly, but 3 doesn't divide 10 evenly. So 2 is the number that divides 6 and 10. Then what about the greatest common factor for variables? So you check that the variable is present in both terms, so the variable is x. Now, what is the lowest exponent? The lowest exponent is 2. So that means that the greatest common factor for this is going to be 2x squared. So then the second case, we have 15y to the 5th, negative 9y to the 4th, and 27y to the 3rd. So first, the greatest common factor of coefficient is a number that can divide 15, 9, and 27. What is that number? that number is 3. So then the greatest common factor of variables is going to be first the variable that is present in all of the terms is y, and the lowest exponent is 3. So that means that the greatest common factor is going to be 3y cubed. Finally, we have x to the 5th, y to the 3rd, x to the 4th, y to the 4th, and x cubed y squared. So the greatest common factor of coefficients, we have coefficient 1 here, 1 and 1, so 1 is the greatest common factor of coefficients. Then the greatest common factor of variables. I have x present in the 3 terms, so x present, and also the lowest exponent is 3. I also have y present in all terms, and 2 is the lowest exponent, so the greatest common factor for these 3 terms is x cubed y squared. So now we're going to start doing our first operations of factoring. So we're going to start with factoring out. We're going to do factoring out the greatest common factor. The greatest common factor. This is on page 422. I'm going to write the steps. You're going to start by determining the greatest common factor of all terms in the polynomial. Remember, we are factoring polynomials. Then, once you have that, this is the crucial part. I'm doing this in a different way than your book suggests. This is the way that I learned this. So you're going to write the greatest common factor write the greatest common factor multiplying the polynomial and divide each term of the polynomial by the greatest common factor. So you're going to have something that your greatest common factor, then parentheses, you're going to write your polynomial, and every term of the polynomial is going to be divided by the greatest common factor. Then you forget about the greatest common factor. You're going to work with the parentheses only. So you're going to simplify the fractions because you're going to have fractions inside. You're going to simplify the fractions inside of the parentheses. And this is important, and you're going to keep the greatest common factor outside of the parentheses. So don't be tempted to do the multiplication. Don't be tempted to apply the distributive property because you're going to destroy your work. So you leave the greatest common factor outside of the parentheses. Don't touch it. So we're going to work some exercises to see this. So I'm going to work example 2 on page 422. So example 2 on page 422. So we're gonna factor 5x squared plus 30. So we're gonna start first finding the greatest common factor. So first, the greatest common factor of coefficients is just 5, because 5 divides 5 and 5 divides 30. And the greatest common factor of variables is just 1, because the variable only appears in the first term but is not present in the second term. So your greatest common factor here is just 5. Yeah, remember, when the variable is not present in all of the terms, your greatest common factor for the variable is just 1. So now we're going to apply the second step. We're going to write the greatest common factor multiplying the polynomial, but we're going to divide every term of the polynomial by the greatest common factor. So this step is crucial. This is different from your book. Then you simplify what is inside of the parentheses. So don't touch your greatest common factor, this outside. So 5 over 5 is just going to be 1. These two cancel, so you're going to end up with x squared. And then positive divided by positive is going to be positive. 30 divided by 5 is going to be 6. So this is your first factoring. So that's the answer. So if you apply the distributive property, you're going to get this expression. If you do factoring, you get this expression, and this is a cycle. So sometimes we need to apply distributive property and we get this expression. Sometimes we need to factor expression and we go in this direction. So that's example 2. Now we're going to work 2 more examples. So I have example 3 on page 422. So we're going to factor 18x cubed plus 27x squared. So first, we need to get the greatest common factor. So greatest common factor of coefficients. So what is the number that divides 18 and 27? You can say 3, but there is a number that is greater than 3 that still divides 18 and 27 evenly. That number is 9. So you need to look for the greatest number that divides, the greatest integer that divides all your coefficients. So now the greatest common factor of variables, you see that x is present in both terms, so x, and the lowest exponent is 2. So the greatest common factor for this algebraic expression is going to be 9x squared. So in the second case, we're going to write 9x squared outside of the parentheses. Then I'm going to write every term divided by the greatest common factor, my original polynomial divided by the greatest common factor. Then we don't touch the greatest common factor outside. We simplify what is inside of the parentheses. So 18 divided by 9 is going to be 2. X cubed divided by x squared is just x. 3 minus 2, 1, so it's 2x. Then 27 divided by 9 is going to be 3. And x squared divided by x squared is just 1. So this cancel to this because they are like, they are equal. So you can cancel. So this is the answer. So now let's work one more example. We have example 4 on page 423. we're gonna factor 16x to the 5th minus 12x to the 4 plus 4x cubed. So we start with the greatest common factor. So the greatest common factor for coefficients, what is the number that divides 16, 12, and 4? You're gonna see that 4 is gonna be that number. The greatest common factor of variables, you see x in all of the terms, and you see that 3 is the lowest exponent, so the greatest common factor is going to be 4x cubed. In my second step, I'm going to write that greatest common factor outside of the big parentheses, and then I'm going to write every term of the polynomial divided by the greatest common factor that we found in the previous step. And finally, we keep our factor outside of the parentheses, don't touch it. And don't forget to write it also. So 16 over 4 is going to be 4. X to the 5th over x cubed is going to be x squared. Negative 12 over 4 is going to be 3. X to the 4 over x to the cube is going to be x. Then this quantity is the same as this one, so this is just 1. When you have the numerator equal to the denominator, then the fraction equals 1. I have 2 more exercises, and then you're going to have some exercises to work on. So I have now example 5 on page 423. We're going to factor 27x squared y cubed minus 9xy squared plus 81xy. So first, the greatest common factor for coefficients is going to be, again, 9, because 9 divides everything, every coefficient. And the greatest common factor for variables, we have x, and the lowest exponent is 1. We have y, and the same thing, 1 is the lowest exponent, so the greatest common factor for this trinomial is going to be 9xy. Then we write the greatest common factor outside of the parentheses, and inside we're going to write every term divided by 9xy, which is the greatest common factor. And then we simplify. So this is very boring for you because we are doing the same thing every time. So we keep the greatest common factor outside. 27 divided by 9 is going to be 3. X squared over x is just x. Y cubed over y is just y squared. Then negative 9 over 9 is just 1. X over x is just 1. Y squared over y is just y. And then plus 81 over 9 is 9. X over x is 1. Y over y is 1. So this is the final answer for example number 5. I have one more example, and then you're gonna work some exercises. So this is gonna be example 6. Example 6 is on page 424. So we're gonna factor negative 18a to the 4b cubed plus 6a squared b squared minus 15a cubed b. So this is about factoring with a negative coefficient in the first term. In the leading term, we have a negative coefficient here. So when you have that, you're going to include a negative sign as part of the greatest common factor. So first, the greatest common factor of coefficients. Since the leading coefficient is negative, you're going to need to use that negative there. Now, what is the number that divides 18, 6, and 15? It's 3. Then the greatest common factor of variables is going to be a that appears in every single term, and square is the lowest exponent. Then b appears in all of these terms, and the lowest exponent is 1. So the greatest common factor is going to be negative 3a squared b. So when the leading coefficient is negative, your greatest common factor is going to be also negative. Then we write negative 3a squared b that multiplies negative 18a to the 4b cubed over negative 3a squared b plus 6a squared b squared over negative 3a squared b minus 15a cubed b over negative 3a squared b. So the three terms are divided by the greatest common factor. So finally we simplify. So we're going to get negative over negative is going to be positive. 18 over 3 is going to be 6. A to the 4 minus 2 is 2. B, 3 minus 1 is 2. Positive over negative is negative. 6 over 3 is going to be 2. A squared over a squared is 1 because they are the same. B squared over b is going to be b to the 1. Negative over negative is going to be positive. 15 over 3 is 5. A cubed over a squared is going to be a 3 minus 2, 1. B and B cancel to each other. They cancel to each other. So that's the final answer. Now you're going to solve some problems. And we're going to end up this section by covering factoring by grouping. So you're going to start with 6.1 exercise set on page 427. You're going to factor out the greatest common factor. 20. 32x minus 24. 26. 6x cubed plus 15x squared. 32. 12x squared minus 4x to the 4. 40. 6x minus 4x squared plus 2x cubed. 48 is going to be 18x cubed y squared minus 12x cubed y minus 24x squared y. So these are your exercises for factoring out the greatest common factor. Take 10 more minutes, solve all of them. This is the point where you need to solve all the assignments, all the problems in the assignment to get ready for the exams. So we're going to end up this section by working factoring by grouping. That's a very important process that we need to talk about, factoring by grouping, is on page 424. The idea is that if you don't find a greatest common factor for all the terms that you have in your polynomial, maybe if you group the terms, you might be able to find a greatest common factor for every group in your polynomial. And the idea is that you need to find a factoring by grouping that is going to lead you to get a binomial common factor. So the best way to understand this is by solving a couple of examples. So this is like a factoring process that is going to contain two main steps. First, you're going to split the polynomial. You factor those parts independently. But at the end, you are looking for a common factor for those final factor expressions. So let's work example 8. Example 8 on page 425. So we have to factor x cubed plus 4x squared plus 3x plus 12. So you start with the idea of trying to find a greatest common factor for the entire expression. You can see here that the greatest common factor for the coefficient is just 1. The greatest common factor for the variables is also 1 because x is not present in all of these terms. So your greatest common factor is just 1. So you cannot do anything with this. So maybe you can group the terms. So this is completely arbitrary. So sometimes you need to find different ways to split the terms, to group the terms. But usually in the way the problems are written in your book, usually the first two are going to be the first group and the second two terms are going to be the second group. So we're going to have x cubed plus 4x squared plus 3x plus 12 group in this way. So this is going to be my first group and this is going to be my second group. So this is group 1 and this is group 2. The idea is that we're going to work this. We're going to get the greatest common factor for this group, the greatest common factor of this group. Once you get the greatest common factor for each group, the idea is that this binomial here, this binomial is going to be equal to this binomial. So that's the plan. If you get that, if you get this binomial to be the same as this one, then the next step is you're going to factor the binomial out. So at the end of the day, you're going to get the greatest common factor 1 plus the greatest common factor 2 multiplying that binomial. So that's this is like a summary of the process. So let's continue with this example. So let's start factoring factoring the greatest common factor for each of these groups. So I'm going to write here again my original polynomial, and then I'm going to use these curly braces to indicate the process I'm going to follow. So I'm going to factor the first group. So what is the greatest common factor for the first group? So the greatest common factor for the first group is going to be first, the greatest common factor for coefficients is just 1. The greatest common factor of variables is going to be x squared. So the greatest common factor is going to be x squared. I'm working with the first group, so I'm going to write x squared that multiplies x cubed over x squared plus 4x squared over x squared. And finally, I'm going to get x squared that multiplies x plus 4. So those are the 3 steps apply to the first group. Now, the second group, I'm going to have a plus here. So for the second group, what is the greatest common factor of coefficients? It's just 1 because there is no other number that can divide 3 and 2 evenly. The greatest common factor of, okay, but I'm having here, this is, it should be 12. So that changes the greatest common factor of coefficients. The greatest common factor of coefficients in this case is not going to be 1. It's going to be 3. Okay, so it's very important that you copy your problems correctly. Otherwise, that's a source of mistakes. So what is the greatest common factor of variables in this case? It's just 1 because x only appears on the first term but not in the second one. So in this case, for the second group, the greatest common factor is going to be just the number 3. So I have a plus here that I'm going to keep throughout the process, but now I'm writing the factor, the greatest common factor for the second group outside, and then I'm going to write every term of the second group divided by that greatest common factor. So I'm going to keep the number 3 outside of the parentheses, and 3x divided by 3 is just going to be x because 3 and 3 cancels, and 12 divided by 3 is going to be 4. So now you can see my first greatest common factor, the binomial, the second greatest common factor, the binomial, and you see that the binomial is the same. If you don't get the same binomial, if you don't get the same binomial, I call this the common binomial, then that factoring by grouping didn't work. You need to group the terms in a different way to see whether you can get a common binomial at the end of the process. Now it's very easy because the answer is just get the common binomial here, and then the other factor is going to be just the coefficients of the greatest common factors that you have outside of those parentheses. It's like hiding this and hiding this, and you can read x squared plus 3 if you hide the binomials. You can read x squared plus 3. So that's the final answer. So I'm going to work one more example, and then you're going to have work to do. Continue because we have another section to finish this lecture. So this is example 9 on page 426. So we're going to factor. We're going to factor xy plus 5x minus 4y minus 20. So you can see that there is no greatest common factor for the 4 terms that might be interesting or important to factor out. So we're going to start doing factoring by grouping. So we're going to have these 2 groups. So what is the greatest common factor of this one? Coefficients is just 1. Variables is only x. So the greatest common factor for these 2 terms is just x, because x is present in both terms, y is not. So that means I'm going to write x that multiplies xy over x plus 5x over x. So in the first case, I'm going to get x that multiplies y plus 5. So that's with respect to the first group. With respect to the second group, what is the greatest common factor? I have both terms. The leading one is negative, so the greatest common factor is going to be negative. What is the number that divides both 4 and 20? It's going to be 4. And the variable y is the only variable here, but it's not present in both terms. So my greatest common factor is going to be just negative 4. So I'm going to write negative 4 that multiplies negative 4y over negative 4 minus 20 over negative 4. So we simplify this. So negative 4 over negative 4 is just 1. We end up with y. Negative over negative is going to be positive. 20 over 4 is going to be 5. And you see that we did the right thing because we are getting the common binomial. So we just write the common binomial and then the coefficients of the, not the coefficient, the greatest common factors for each group. So x minus 4. Remember, it's like hiding the binomial and reading what is left, x minus 4. So that's the answer. So we have, and the common binomial is y, not x, is y plus 5. So be careful with every single step, because in every step we can make mistakes. We can just change variables. So you're gonna work 6.1 exercise set on page 427. You're gonna do factoring by grouping. You're gonna factor by grouping the following exercises. 76 is just x cubed plus 6x squared minus 2x minus 12. And 82 is just 10x squared minus 12xy plus 35xy minus 42y squared. So this is these are the two problems that you're going to solve for this section. So I'm going to give you 10 minutes to solve these problems, and we're going to start now with the last section corresponding to this lecture, which is going to be section 6.2. Now we're going to start section 6.2. It's about factoring trinomials whose leading coefficient is 1. This is on page 429 in your book. So we're going to use a method that is going to be useful for both the cases that we're going to work on section 6.2 and section 6.3. So this is going to be our general method. So we're going to be factoring trinomials usually of this form. So there are going to be trinomials that are going to be quadratic expressions. So you're going to have ax squared plus bx plus c. The only difference between section 6.2 and section 6.3 is going to be the value of the first coefficient, of the leading coefficient is going to be the value of a. So when a equals 1, then we are working on section 6.2. When a is different than 1 or greater than 1, these are going to be the problems that we're going to cover in section 6.3. But the method is going to be the same in both cases. So I'm going to give you the method, the AC method. These are the 3 steps. So you're going to look for factors of the product AC. So you're going to multiply AC, and then those factors should be in a way that when you add those factors, you're going to get B. And once you find these 2 factors, you're going to rewrite this expression, the middle term. You're going to break this expression in 2 parts. So you're going to rewrite B as the sum of those 2 factors. And with that, you're going to get now 4 terms, then you're gonna do factoring by grouping. So you're gonna factor the 4 terms in the way that we did it before. It is important that you follow this method. It's gonna be very helpful because later, when you have coefficients different than 1, for you it's gonna be very easy to factor those trinomials, because I know that there are methods that we learned in the past that you just find the factors and then just write the binomials. Try to do this exercise. It's going to be important for you to acquire your skills to do a better algebra in the future. So let me start with examples, and I'm going to tell you why following these steps are very important. So we're going to start with example 1. Example 1 on page 431. We're going to factor x squared plus 6x plus 8. So you can see here that the leading coefficient is 1. You can also see that there is no greatest common factor here that you can factor out of these 3, because the greatest common factor for coefficients is just 1, and for variables is also 1 because x is not present in all terms. So you cannot factor out your greatest common factor. So you're going to start looking for 2 factors. I'm going to use the square brackets to indicate that we're going to multiply 2 numbers, and we're going to get AC. AC is just 1 times 8, and we want those 2 numbers satisfying the sum. So when you add these 2 numbers, you're going to get B, which is going to be 6. So this is a process where you're going to do some guessing, right? So I don't like guessing, but in math, sometimes we need to do that. So you're going to see that, for example, you can try 4 times 2. And if you get the product, you get 8. If you get the sum, you get 6. So these 2 numbers are satisfying those 2 conditions. So 4 and 2 are going to be my numbers. So in this case, I'm going to write x squared plus 6x plus 8. I'm going to break this into parts. So I'm going to get 4 and 2. In this case, are x's, so 4x plus 2x. That's the way I'm breaking the middle term. And then I write the rest, so x squared plus and 8. So now I have my trinomial in 4 terms now. It's now a polynomial with 4 terms. So I'm going to do factoring by grouping. So I'm going to factor the first group. So what is the greatest common factor here? You're going to find that x is the greatest common factor. That multiplies x squared over x plus 4x over x. So you're going to get x that multiplies x plus 4. Then with respect to the second group, the greatest common factor is only 2 because x only shows up at the first term but not at the second. So this is going to be 2x over 2 plus a over 2. So this is going to be 2 that multiplies 2 over 2 is just 1. So you're going to get x plus 4. We got the common binomial, so that's great. So we're going to write that common binomial, and the other binomial is going to be composed by using the greatest common factors, so x and 2. So these are the numbers that we found, 4 and 2, and usually once you find the numbers, you just write this automatically, but with no explanation in your mind, you're just following a recipe. You used to follow a recipe because the book said, if you find the 2 numbers, just write this as your answer. But it's better if you follow this process, because now you're understanding why you are getting this. So that's what you're gonna do, especially sometimes It's not easy to move from here to here because there are more variables involved, and then you might make mistakes. I'm going to work more examples. So the next one is going to be example 2. So I have, let's work that example on the next page. Example 2 on page 432. I'm going to factor x squared minus 5x plus 6. So again, I need two numbers. Then when I multiply them, I get a times c, which is in this case just 6. And if I add up those two numbers, I'm going to get b, which is negative 5. So I need candidates. So in this case, 3 times 2 is going to be 6, but 3 plus 2 is going to be 5. So it doesn't work. So let's try now 6 times 6 times 1, you get 6, but 6 plus 1, you get 7. So we are guessing negative 3 times negative 2, you're going to get 6. And negative 3 plus negative 2, you are adding two negatives, you're going to get negative 5. So I found the values. Those are negative 3 and negative 2. So we're going to rewrite this trinomial as a polynomial with 4 terms. We're going to break the middle terms. We're going to write negative 3x, negative 2x plus 6. And here you have x squared. Now we're going to factor by grouping. So in the first case, you have x that multiplies x squared over x minus 3x over x. Leading coefficient is negative, so it's going to be negative 2 that multiplies negative 2x over negative 2 plus 6 over negative 2. So you're going to get x that multiplies x minus 3 minus 2 that multiplies x minus 3. So we are getting our common binomial x minus 3. Remember, we need the common binomial in both terms, and then the greatest common factors, x minus 2, which are these ones, right? So you go directly from here to here, but you miss this part, this learning. Example 3 on page 433. The important thing of following this process is that now you're going to be well prepared to the next section. So you're going to go directly to solve the problems. So on example 3, we have to factor y squared minus 2y minus 99. So we have two factors that the product is going to give me AC, which is negative 99, and their sum is going to give me B, which is negative 2. So 11 times negative 9 is going to give me negative 99, and the sum is going to give me positive 2, so it's not what I need. I need the other way, so I'm going to use now negative 9, positive 9. So that is going to give me again negative 99. But the sum is going to give me now negative 2, so what is what I need. So these are my two factors. So I'm going to break this into negative 11y plus 9y, and the rest is going to be written just by bringing down those terms. So now I'm going to do factoring by grouping. So this factoring by grouping is very simple. It's going to be y that multiplies y minus 11 plus 9 that multiplies y minus 11. I'm skipping some steps. You know how to do this. So you're going to get y plus 9 that multiplies y minus 11. Okay, I'm going to go now example 5. Example 5 on page 433. We're going to factor x squared plus x minus 5. So again, we need two numbers whose product is going to be AC, in this case negative 5, and those numbers, their sum is going to give me B, which is positive 1. So we need to look for numbers, so you can take a long time and you are not going to find any factors, or no factors satisfy these conditions, these two conditions. So that means that there is no factoring possible. There is we cannot factor. We cannot factor the trinomial over the integers. So that means that we have a prime trinomial. So this is a prime trinomial. So nothing can be done to solve this problem. So let's work one more example, and then you're going to have some work to do. And with that, we're going to finish our lecture today. So this is going to be example 7. On page 434, we're going to factor completely 3x squared minus 15x squared minus 42x. So when you say, when you read completely, that means that you need to be careful that you can get the greatest common factor for the entire expression. So in this case, you can see that the greatest common factor for coefficients is going to be 3. And the greatest common factor for variables is going to be x. So we need to factor out first the greatest common factor. So we're going to write 3x that multiplies 3x squared over 3x minus, and this is 3x cubed minus 15x squared over 3x minus 42x over 3x. So we work on the terms inside of the parentheses. So we're gonna get x squared minus 15 divided by 3 is gonna be 5x. And then 42 divided by 3 is gonna be negative 14. So now I have this factor, and I have a trinomial that I'm going to factor by using the AC method. So to factor this, I need two numbers whose product is going to be AC, in this case negative 14, and their sum is going to be B, so in this case negative 5. So let's see, 7 times negative 2 is going to be negative 14. And the addition of these two numbers is going to be positive 5. So this is not working. So then we try the other way. So negative 7 times positive 2. This is going to be again negative 14. But this time the sum is going to be negative 5, which is what I want. So I need these two numbers here to break the middle term. So I'm going to have something like negative 7x plus 2x. I'm breaking the middle term. Then I have x squared here, and I have 3x here. Don't forget your greatest common factor. So now I'm going to factor by grouping these two expressions. So I'm going to write 3x, and then I'm going to use square brackets because I'm going to use more parentheses to do my factoring by grouping. So what is the greatest common factor of x squared and negative 7x? Is going to be just x that multiplies x squared over x minus 7x over x. What is the greatest common factor of the second group? Is going to be just the number 2 that multiplies 2x over 2 minus 14 over 2. So then we have that we're going to get x that multiplies x squared over x is just x minus 7 plus 2 that multiplies x minus 7. So we get the common binomial. That's important. Otherwise, we are making something wrong. So I'm going to get 3x. Then I'm going to create a factor with x and plus 2, the greater common factors, and then the common binomial. So that's the final answer for this problem. So now you're going to have to solve 5 problems. Solve all of them because this is important to acquire the algebraic skills that you should to pass this class. So 6.2 exercise set on page 436. So you're going to factor completely. So we have problem 16 is y squared plus 5y minus 24. Then problem 28 is w squared plus 12w minus 64. 54 is 3x cubed minus 15x squared plus 18x. Then problem 58 is y to the 4 minus 12y cubed plus 35y squared. And finally, 68 is negative 16t squared plus 80t plus 96. So that's your work. You're going to compile all your exercises that you solved throughout this lecture. You're going to take screenshots. You're going to use CAM scanner or PDF scanner in your smartphone to get a PDF file. And you're going to submit that PDF file through Canvas on the corresponding classwork assignment. So if you have questions, just send me an email with screenshots of your work where you have the question, and also indicate to me the number of problem and the page of the book that you where you got that problem.